Continuing with our example from last time where we flip a coin, then roll this colorful cube, we have this sample space. Let's define some events here. Say H is the event, a head is flipped. So you could describe it by simply writing it out like that, a head is flipped. Or you could describe it by writing it as a set and just listing out all the outcomes in that event. So when a head is flipped, I'm just going to go through the sample space and I'm going to pull out all the outcomes where a head is flipped. All the ones. Heads white, heads yellow, heads red, etc. Heads blue, heads green. Heads orange. Likewise, you could define an event, let's say R means that the red face appeared on the die. On the cube, I guess. And you could write out the outcomes in that event. So I just go through the sample space and pick out all the outcomes in my sample space where this event occurred. So where a red face appeared on the cube. So that's just these two. Heads red and tails red. So that's it. For any event you can reasonably precisely define, you can go through the sample space and just check whether each outcome results in that event occurring, and then you can list out those outcomes. And that's why every event you can think of as a subset of the sample space. Let's do maybe a slightly different one. Suppose now, how about something totally different? Imagine that you measure the temperature of a solution, and let's define a sample space that could give us all the possible results of that measurement. Let's suppose, just for simplicity, we're measuring in degrees Kelvin, because that way we have a nice starting point at 0. You can't have negative temperature in degrees Kelvin. So in that case, for a sample space, let's take all the real numbers that are bigger than or equal to 0. Remember, reminder of this notation, this means it's the set containing all of these things, all x's in the set R, so all real numbers that satisfy this property being non-negative. So in this case, you have infinitely many elements of the set, and in fact, this is called an uncountably infinite set. You can't list all these real numbers, so you have to write it in a more compact way like this. And similarly, if you have some events, for most of these events, you might not be able to list all the outcomes in the event. So for example, let's have an event called, how about, use that letter already, let's just call it E, which is, let's say the temperature is above, I don't know, 80 degrees Kelvin. Well then, how would you write this out as a set? You can't list all the outcomes. So instead, let's use this notation again. You can see that it's just going to be all the real numbers, but we want the temperature to be above 80 degrees, so we're just going to take the real numbers that are above 80 degrees Kelvin. Great. Subtle thing, I said above, so really above. Not above or equal to. It doesn't really matter in this case. Not a big deal, but I did say above. This is above.